alaikum wa rahmatullahi wa barakatuh. Welcome everyone to lecture 9 of Discrete Mathematics ITDR2103. Lecture 9 is all about generating function. In this session, we will discuss about what do we mean by generating function. Then we will see on adding and multiplying two generating function, and then we can have a look on the usage of generating function to solve counting problems and recurrence relation problems. Now let's start with the definition of generating function, and then we can go forward on solving the problems. Generating function is when I have a sequence A0, A1, AK, etc. of a real numbers. Okay, then I can have three forms for the sequence. The first form calls as a summation form, where we write the generating function as g of x, which is the name of the function. Then we do have here sigma, starting from k equals 0 until infinite, for all a k x to the power k. So this is the first form of generating function, which is called as summation form. The second form calls as series form, where when we just substitute the value of k from here. So we start off a0 x to the power 0. Then we go for a1 x to the power 1. Then a2 x to the power 2. And we keep going, etc. until we reach ak x to the power k. Alright? Summation form, where we have a sigma k0 until infinite ak x to the power k. This summation form can be converted to series form, where we got it as a sequence in here. And the third form is a closed form, where we have like a rule. If it's applied, it will reach me to the series form or summation form. So generating function is basically converting one form to each other. And we can see this in the upcoming example. There is a slight note here says that the generating function for ak given above is sometimes called the ordinary generating function. So generating function has sometimes another alternative, which is called as ordinary generating function. All right, before we go on the examples, we need to identify some rules here, where we will use to solve the upcoming problems. The first rule says that the closed form a minus x to the power minus 1 is equal to 1 over 1 minus x, which is equal to the series form 1 plus x squared plus x3, x to the power 3, etc. The second form is 1 plus x to the power minus 1, which is equal to 1 plus x. And here it gives me the same what I've got in the first rule. However, we can see here the alternative of the sign. So here 1 minus x plus x squared minus x cubed, and so on. The third rule says that 1 minus x to the power minus 2 is equal to 1 over 1 minus x to the power 2, which equal to 1 plus 2x plus 3x squared plus 4x cubed, and so on. And the fourth closed form, which is 1 plus x to the power minus 2, is equal to 1 over 1 plus x to the power 2, which equal to 1 minus 2x plus 3x squared plus 4x squared. So when it is power 1, then the numbers beside x is equal to 1. Okay? If it's minus, then here we will have the same sign, which is plus. If it's plus, then it will be alternativity each time. So minus plus minus plus. For the power minus 2, we can see here it each time add by 1. So 1, 2, 3, 4, 5, 6, etc. If it's minus inside, then we've got that all will be plus in the series form. However, if it's plus, then we can see the alternative sign here, which is minus plus minus plus. Now for those 4 rules, it considered as infinite series. So it produced me the infinite series. The last rule, or the 5th rule, where I've got that 1 minus x to the power n plus 1 over 1 minus x is equal to 1 plus x squared plus x cubed until xn, which we call as the finite series. So it produced me the limited number of sequence. Okay? Now what we will have to do is we use those rules in order to find the generating function of a sequence or a closed form. Let's see this example. Here it's asked to write the generating function for the sequence AK with AK equal to 3. Now we usually start solving such sub-problems by calling the first summation form. Okay? The summation form of this problem is equal to jx, name of my function, equal to summation, starting from k equal to 0 until infinite. Okay? Here we got inside as a k x to the power k. This is the summation form. Now we substitute the value of fk, ak, with the value given in the example here. So this is equal to infinite, k equals 0. ak here is equal to 3, then x to the power k. Okay? Now, if I just use the summation form to produce the series form, how to do so? By converting each time the value of k. Okay? Now, this is equal to a0 x to the power 0 plus a1 x to the power 1 plus a2 x to the power 2, and we'll keep going. Now if I got that ak is equal to 3, then I will have it as 3 x to the power 0 is 1, so we have it as 3. Then 3 to the power times x, then 3x squared and 3x cubed, and we will keep going. So what I did is I just substitute the value of k by 1, 2, 3, 4 until infinite. So here we got that the generating function, the j of x is equal to 3 plus 3x plus 3x squared plus 3x cubed plus etc. Okay, because it's here it's infinite. All right, now in order to reach the closed form, We will have here, we can see here that 3 is repeatedly on each term. So what we can do is we can have 3 as the common factor, and then what we left inside is 1 plus x squared plus x cubed plus etc. And if you remember, from the first rule we got this series form is equal to 1 minus x to power minus 1. So this rule we got it here. If I got the series 1x plus x squared plus x cubed, then this is equal to 1 over 1 minus x, which equal to 1 minus x to power minus 1. So from the first rule, we substitute the series form to 1 minus x to the power minus 1. Then we can have like the closed form of this problem is equal to 3 multiplied by 1 over 1 minus x, which equal to 3 over 1 minus x. Alright, let's see another example. We need to find the generating function for the sequence AK if AK is equal to k plus 1. Again, we start from the summation form. Alright? From the summation form, we say that gx is equal to sigma from 0 until infinite, then ak x to the power k. Now all what we need to do is we just substitute the AK with the one mentioned in the question here. So here we got that Jx is equal to sigma k0 to infinite. AK is equal to k plus 1, then x to the power k. Okay? So in order to solve this summation form, we need to find the series form. Okay? Now the series form says is nothing but applying the summation. So each time we will substitute the value of k starting from 0 until infinite. So here we got that g of x is equal to, first, if we substitute the value of k by 1, we got it as 1 plus 1. Sorry, we start from 0. So here we got that 0 plus 1, then x to power 0. And when k is equal to 1, then 1 plus 1 x to power 1 plus 2 plus 1 x to power 2 plus 3 plus 1 multiplied by x to power 3. And we keep going until infinitely. So this is equal to 0 plus 1 is 1, x to the power 0 is 1. So here we got that 1 plus 2x plus 3x squared plus 4x cubed infinitely. Okay, so here we got our series form. Now from the rule we got there, which is rule number 3. If you go back to the rules, okay, I can have the closed form as j of x is equal to. If you go back to the rules, we can see that if it's here 1, 2, 3, 4 and the sign is plus plus plus, and we got the x as x1, x to the power 2, x to the power 3, then we can have it as it is 1 minus x to power minus 2. And here we got the summation, the closed form, sorry, where it is also equal to 1 over 1 minus x to the power 2. Again, the third example is here. We need to find the generating function for the sequence where ak is equal to 2 to the power k. Again, starting from the summation form. Okay. Here we got that g of x, is equal to summation starting from 0 until infinite. Now we will go straight forward on substituting the value of ak with 2 to the power k. So here we got that summation sigma k0 until infinite 2 to the power k x to the power k. Okay. Now, from the summation form, I can produce the series form by substituting the values of k starting from 0 until infinite. So from here, we can see that g of x is equal to 2 to the power k, which is 0, x to the power k, which is 0, plus 2 to the power k, 1, x to the power k, 1, plus 2 to the power k, 2, x to the power k, 2, plus 2 to the power 3, x to the power 3, and we'll keep going infinitely. So from here we can see the series form as 1 plus 2x plus 4x squared plus 8x cubed infinitely. And here we produce the series form. Now, if we go back to the rules, we can see that before we go back to the rules, we can just convert this to a same form. So we can have the series as 1 plus 2x, and we all know that 4 is 2 to the power 2, and here we got x to the power 2, so I can have it as 2x to the power 2 plus 8 is x cubed, and here we got 8 is 2 cubed, and here we got x as 3 cubed. So it's something like 2x to the power 3, and so on. Okay. Now, if we go back to the rules, we can have that the closed form of the following sequence is equal to 1 minus 2x to the power minus 1, which is equal to 1 over 1 minus 2x to the power minus 1. And here we solve this problem. Okay, we got a small note here. We can define the generating function for finite sequences of real number by extending a finite sequence of A0, A1, A2, AN into infinite sequence. And so we can change the finite sequence to infinite by setting the AN plus 1 to 0 and AN plus 2 to 0 and so on. So we got the generating function for the finite sequence as A0, A1 x1, A2 x to the power 2 until AN x to the power n. Now let's see this example here. In this example, we need to find the generating function for the following finite sequence. I got 1, 1, 1, 1, 1, 1. So here we can see that n is equal to, if we start from 0, we got that n is equal to 1, 2, 3, 4, 5, and 6. So n is equal to 5. If we start from 0, so here we got 0, 1, 2, 3, 4, and 5. Okay? So, from the summation form that produce the following series, we know that j of x is equal to, here we got sigma starting from 0 until 5. Okay, I got as ak times x to the power k. Okay, now since it is a finite, then the series form of this function is equal to a0 x to the power 0 plus a1 x to the power 1 plus a2 x to the power 2 plus a3 x to the power 3, a4 x to the power 4, and a5 x to the power 5. So why we stop here? Because in our function or generating function says that we start from 0 until 5. And because I've got here 6 terms. Okay, now from the sequence we can see that the series form is equal to 1 plus x squared plus x cubed x to the power 4 plus x to the power 5. If we go back to the rules, we can produce the closed form of this function as it is equal to 1, which is the fifth rule, by the way. So 1 minus x to the power 6 over 1 minus x. And why 6? Because n here is equal to 5. So here we got as 1 minus x to the power n plus 1, which is 6. All right? And here we solve this problem. How about if we got the same sequence, however, it is infinitely. There's no end. And we got something new here as x its coverage. So we will see what do we mean by this. Okay, now again we start with summation form. This time we said we got the same sequence, however it has no ending. So the summation form of the sequence is equal to sigma starting from 0 until infinite. Then we got it as a k times x to the power k. Okay, where this give me the series form as what we can see here. Now if I just try to use this rule, so I will get as a0 a1 x to the power 1, a2x to the power 2, a3x to the power 3, and so on. So from here we can see that my series form of the sequence is equal to 1 plus 1x plus 1x squared plus 1x cubed, and so on. So the numbers in the sequence is basically represent the constant I got in the front of x, which is the a. So from here we can see, if we go back to the rules, that this sequence can be represented as the rule of 1 minus x to the power minus 1, which is equal to 1 over 1 minus x. All right, so here we solve the first part of the question. The second part says that what is the value of x it converts. So here the value of x usually is by taking the term here. So here we got as x should be always less than 1. All right. Okay. Another sequence is here. If we got this sequence as 1, a to power 2, a to power 3, and then we need to find the value the series converts. Okay? Yalla. Summation form. So the generating function as a summation form is equal to sigma k0 until infinite, and why infinite? Because I have the 3 dots here, ak x to the power k. Okay, this is produce the series form where jx is equal to a0 plus a1 x to the power 1 plus a2 x to the power 2, a3 x to the power 3, and so on. Now all what we need is substitute the value of a by the value in the sequence here. So here we got that it is equal to 1 plus ax plus a square x squared plus a cube x cubed plus etc. Okay, now if we go back to the rules we discussed at the beginning of this session, we can have that the closed form of such series is equal to 1 minus ax to the power minus 1, which equals to 1 over 1 minus ax. Okay, now if we want to find the series converge, then we need to take the term itself. So for all ax is starting from 1, we need just to take a, put x alone, so this will be equal to x is less than a 1 over a, and for sure a should not be equal to 0. Okay, one more example. We need to find the generating function for the sequence 1, 2, 4, 8, and also we need to find the value the series converts. Okay, all right, starting with summation form. Let's make it short now. So g of x is equal to sigma starting from 0 until infinite ak x to the power k. Okay, and this produce me the series form, so we'll have it as SA. The series form produced by the summation form is A0 AK x to the power, A1 x to the power 1, A2 x to the power 2, A3 x to the power 3, and so on. So from the sequence I can see that my series form is equal to 1 plus 2x plus 4x squared plus 8x cubed plus so on. Okay, now we saw this example before, and we need just to make a is equal in each term. So what we can do is we can convert the series form to 1 plus 2x plus 2x to the power 2 plus 2x to the power 3 and so on. So from here we can find the closed form as g of x is equal to 1 minus 2x to the power minus 1, which equal to 1 over 1 minus 2x. Now the series coverage as, if we have it, converge, for, here we got the term as 2x less than 1. In order to left the x alone, we can divide by 2, then we got that it is x less than 1 over 2.